there guys, Erica here from Highway49RC. Thank you so much to my patrons and channel members for making these videos possible. So, a couple of years ago, I picked up a vintage Trinity Brush Cutter that I want to make a custom base for today. This is the cutter. It comes with a few different components, so let me explain how it's supposed to work. You put this piece on top of a motor, you bolt that down, and then you put this guy on top of it, like that, and you can adjust the outer ring up and down with this thumb screw. You can put a little cutting wheel on the motor shaft, and with that you can cut a slot in the brushes, and I believe that is for faster break-in. If that's not correct, do correct me. Or you can put this little insert in there with this knurled grinding bit, and what that will do is put grooves on the face of the brush for faster break-in. This cutter is set up for stand-up brushes, lay-down brushes, and P94 brushes for those curious. So basically every brush type except cylindrical brushes can be cut with this tool. Now the issue that I don't like about this design is that in order to change out the cutting or grinding attachment, you have to take the whole thing apart because you can't access the set screw without completely disassembling it. So what I want to try and do is make an arrangement where the motor sits next to the cutter, like this, and there's a belt drive that goes from the motor to a custom shaft that will basically take the place of the motor shaft. The custom shaft we're going to make is going to ride on a couple small bearings, and this is the belt drive system that I'm going to be using. This is a belt and two pinions from a belt drive spur and pinion set. I had to get two of them to get two pinions, but this is what's going to be driving from the motor to the custom shaft that the cutters will be attached to. My design is going to look essentially something like this right here. Got the motor, got the belt drive, and then this little piece is this guy, right? So that sits like that on top of a riser block with a slot in it so that I can access the set screw that holds the cutters to the custom shaft. This is a top view of the upside down box, essentially. So the motor will sit right here with some slots so I can adjust the belt tension, and then the cutter will sit right here on top of a riser block. This is a top-down diagram of the riser block, so we've got a main hole, two bolt holes for this guy, so that's going to bolt to there. There's going to be a cross-shaped slot underneath it, and there'll basically be four square legs essentially with holes through them for bolts, and that is going to bolt down on top of our box. Now there's also going to be a bearing cap plate underneath there for our second bearing because I need a way to capture the shaft between the bearings so that the shaft doesn't slide around. Does that all make sense? I've got a nice big block of aluminum here that we're going to cut a couple chunks out of for our upside down box and our riser block. It's 1.25 inches currently, so we're going to knock that down to 1 inch, and then we're going to start drilling holes, milling slots, milling pockets, and all that jazz. So without further ado, let's jump right into it. Alrighty folks, the base of my brush cutter is complete, except for the bore for the bearing. I'm going to do that later at the same time as the bearing cap plate so that my machine settings stay the same. But aside from that, it turned out pretty good. I'm happy with it. There was a ton of chatter doing this full depth cut because I didn't do it in multiple passes, I just did it in one go. There's a lot of chatter, but I got it done. So next up, we're going to make this riser block for the blue part of the brush cutter. So let's get back out there and get to work. Alrighty folks, my riser block is complete. It looks freaking awesome. It was not hard to make at all, but it turned out really cool. Turned out really cool looking. The brush cutter base lines up perfectly with the holes, so that's awesome. In addition, the main hold down bolts fit perfectly. They're countersunk, so they're nice and flush with the top. And there's a gap here because this is where my spacer plate / bearing cap is going to go. It's basically going to be a 3/16 thick plate that sits right on top of the base, and it's going to have a whole board in it for a bearing. And a little while later, I've got my bearing cap plate made. I've sunk the bearing in a little bit farther than the surface so that on my shaft I'll have a shoulder, I guess you can call it, that's going to trap the shaft between the two bearings. So this will go on there, and so there'll be a slight gap between the two bearings that will capture the custom shaft that we're going to make next. And of course everything lines up absolutely beautifully. The bolts go in their holes perfectly. This thing is turning out really good so far. I have just received in the mail the brushed motor that I'm going to be using for the brush cutter. It is a factory-tuned 27-turn stock motor from XIPP, or maybe it's Zip, I'm not sure. But I want to clean up the end belt a little bit. The brush hoods are kind of gross looking. It doesn't need a full rebuild, the commutator looks just fine. But I do want to just clean up the brush hoods real quick, and then we can move on with the build. I got the back end of the motor all cleaned up. Looks pretty good. Looks friggin' awesome on our brush cutter base so far. I'm happy with it. Bolts up to the holes gorgeously, so that's good. Next, let's take a look at our shaft that we need to make. This end of the shaft is for the pulley and the bearing. This flange is what's going to capture this shaft between the two bearings. This is another bearing journal, and this bit is where my tooling goes on, just like that. So I'm going to head out in the garage, find some stock, chuck it in the lathe, and get to work. Guys, this stupid shaft took me 4 tries. I should have been able to do it in 1. It was absolutely ridiculous. This was my first one. Would have been absolutely perfect had I not turned the tooling section down too small. I'm so frustrated that it took me so long to get such a simple shaft made, but here it is. The finish is crap, but it is a shaft. It fits in the bearing, and it also fits in this bearing. It slides together. It doesn't move around. So, by all those rights, it's a successful shaft. The tooling does not quite slide all the way on to this side, but that's okay. And the pulley does indeed slide on to this side quite nicely, just like so. Man, I am so exasperated with this project so far. What I'm gonna do is put this together with the belt, and then we're gonna go do more lathe work, which is not gonna go well, and make some tooling adapters for our brush cutter here. So I was actually able to use my messed up shafts as my extension pieces. I was able to make a nice arbor for the cutoff disc and an extension for the grinding bit here. These then go onto our main shaft, like so. And our main shaft obviously goes and sits in the bearings in the brush cutter base. So as a demonstration, put our main shaft in that bearing, take and put our bearing cap plate on, and then our riser block, and then we'll put the base of the cutter, the top of the cutter, and then I can take and put my extension tooling down onto the main shaft, and it's just at the right level that I can adjust the top of this guy up and down slightly to get the perfect alignment with the cutting tool. And same scenario with the cutoff disc that I just broke. God damn it. I'm gonna have to go get another one. I already broke the first one, but you guys get the picture, right? I think you guys get the picture. And with that, I have just completed the final assembly of my brush cutter and base. I had to use some countersunk screws and nuts for the actual Trinity brush cutter part because I overlooked the fact that these were through holes and not threaded, since this was originally designed to bolt onto a motor. But that's okay. I made do with some countersunk screws and some nuts. There's the belt drive underneath. Everything is hooked up, lined up, hopefully good to go. Okay, crisis averted. I remembered that I have some alligator clips that hook to a battery. This is just a 2S battery, and this should be able to run it no problem. Oh yeah, there we go. That's cooking with fire. Whoa, careful now. That was really cooking with fire. Heck yeah. That is awesome. I've got an old brush here that I want to grind. It's got plenty of life in it, but it's from an old crappy motor that I'm not going to run. So we're going to go ahead and grind this. We're going to give it a grind and give it a cut. So let's set up our cutter here for the grinding tool. Put that down in there. Where's my screwdriver? Now I've got perfect access to tighten my tool down. Give that a little snug. Beautiful. Check that out. Now, I think this is going to be extremely wobbly and not at all practical. I'm really not expecting this to be a practical thing, which is sad. But we shall see. Put the top bit on, put this little guide in, and that looks about good for the height. All right, let's see what it does. I'm a little skeptical here. Okay. Let's grab our brush. Yikes. Okay, that is wild. But check it out. We actually put some serrations on there. Is it even? No, not at all. That completely destroyed the brush. But it works, so that's kind of cool. Let's give this another try. I've adjusted the way that my tooling is, and I set it up so that this knob clamps this center ring down so it's not going all over the place. And I realized the reason that the brush ended up all crooked like is because I put it in the wrong slot. So let's put it in the correct slot this time and see what happens. Okay, well that certainly makes a mess. I'll tell you that much, and it eats the brush like nobody's business. And that is super wobbly and impractical. But there are serrations on that brush. There are definitely serrations on it. The last thing to try, which I'm honestly a little scared about, is my cutoff disc, which I don't think that's gonna go well. I mean, based on the way that this went, I don't think that it's gonna go well. We can't finish this video without trying it, even if this project is a total dud. I've got my cutoff wheel in there. I'm gonna use this knob to adjust the disc to the right location for the brush. And let's put it a little higher, no, a little lower. Yeah, let's try it right there. Tighten that up. I got a pair of safety glasses on because I am frankly very scared of this. I think it is just going to explode when I turn it on because it is so wibbly wobbly. I mean, like, that is just not good, guys. It's just not good. It's too long, you know? Like, it's just not gonna do it. But we can't end this video without trying it, so let's give it a whirl. Yep. It's exactly what I thought was gonna happen. It just explodes, so there's just too much weeble in its wobble, guys. It's just not good. I mean, it was a great attempt. Great idea. But it's just not it. Well, guys, I've been at it all day. I am filthy. My face is dirty. I am sweaty. I'm sorry. You got a dirty Erica on camera right now, but this little brush cutter, grinder, serrator contraption that I decided to come up with, despite my best efforts, it's a dud. This video is a bit of a dud, so I'm sorry about that. I guess I'm just not a good enough machinist yet to produce high enough tolerance parts with high enough quality surface finishes that they fit together perfectly. And since I can't achieve that yet, we have shafts that have a lot of weeble in their wobble. And I guess that's just gonna have to be what it is. And this is just gonna have to go on the shelf as a bit of a learning project, I guess. Because I got a lot of practice on the lathe, I'll tell you that much, because I tried to make that stupid shaft 4 times. If nothing else, I will give myself credit for the belt drive system working out quite nicely. I would definitely do this sort of drive again if I had to. So that's definitely going to go in my little basket of tricks. And I'll also give myself credit for the fit and finish of the milled base. I think it turned out great. I did it all manual, no CNC, except for the bearing bores, which the tolerances on those turned out very nice. So I'll give myself credit for that. Even if as a whole this thing was a little bit of a dud and will probably just end up being a shelf piece, I did a good job on the base. It was a good try. I hope you guys enjoyed all the machining and stuff like that, all the tech talk, because I know that's what a lot of you guys are here for, so I hope you guys at least enjoyed that, even though the final product doesn't really work. That's okay. I guess that's just how it goes sometimes. But with that, guys, thank you so much for watching. I hope you enjoyed. Please do leave a big fat thumbs up. If this does happen to be the first video that you have seen by me, make sure you go down, hit that subscribe button, leave a comment down below. If you want to catch up with me outside of YouTube, head over to my Instagram, at Highway49_RC. If you want to chat with fellow RC and full-scale enthusiasts, head over to my Discord server. And if you want to support me and what I do, consider becoming a channel member or joining my Patreon. As always, links are in the description, and I will see y'all in the next one.